So that's on now. So we continue with our discussion. So here shows some details of the setup ready for those two who just come in. And then what we have, the structure is that the setup we got already in the lab. Use bin 1 as example. You got 500 and 300 at both ends. Very important, don't consider this two because this cancel out when you set the 0 on your on your dial gate, so all cancel out. So that's loading, that's only contribute additional loading to the bin, so we not consider that part. And your really your model should be start from here to here, and then the loading you have the dimension in here. That's all in millimeter. Okay, this is all in millimeter. And we're not using the data to do that, because if you use this one, you put a number in, yes, you can find out the answer, but you need to do many times, and then every time the loading change, you need to do again. So we set up this more general system, like this one, and then use the P1, P2 to represent the loading you apply, and then all the distance is defined in this way. So you only need to give these two, and the length of the bin, and then it depends on this B1 or B2 you have. And then you should be able to use the equation you derive later on to get the results. So what we need to do next part is that we need to find out formulas to represent the formation of the bin. So to find out this formula, we need to use Macaulay method to do that part. So to implement the Macaulay method, we isolate the bin at a location where very close to the right-hand side support, and then we take the left-hand side to consider. So to do this one, we want to get the isolate body, which include all the possible loading inside the structure, and then we can derive a general equation for the bending moment, and then we can use the integration to integrate the equation to find out the deflection later on. So when you isolate this one, what you should have is that I can now simply just wipe off this tiny bit, because the one is not the part we're going to consider, so that's not exist anymore. So we only consider the left hand side. The right hand side is not our concern. So at this edge we cut between this tiny bit and this beam, we have a shear force in here. So this shear force supposed to be a function of x. I use a capital V to represent this one in there. And then at this part, they also should have a bending moment in between this one, because the bending moment at here is 0, but bending moment at this location is not. So we should have a bending moment at this location. So that's the moment is also a function of x, because if x changed, the moment going to be different as well. So once we got this setup, and then we need to find out the equation of equilibrium, rotatory equilibrium, which is the whole body, and then you can take the moment about this point and take moment about this point. So we choose this point because we want to get rid of this one, and then we only interested in this one. Okay, so we only need interest in this one. So when we write out the equation of equilibrium, so I'm going to maybe write out in here, because later on we need to find some space to find out the VL, because VL is not confirmed yet at the moment. So we write out the equation of equilibrium for the bending moment first. So let's assume all the moment about the point, which is point O. Let's give a name to this joint. At this point is the point O. So this point O, that altogether should equal to 0. So and then we also define this is a positive direction. So when we put this together, we have the first one is the VL. And then times the lever arm. Imagine you pin down this one, so the lever arm for this one is going to be x, right? And then that's going to be positive. And then the next one is the P1. So P1 is lever arm is going to be
minus L1.
Is X, is a lever arm is going to be from this one, you pin down this one, so lever arm is going to be from here to here. And then that is X, and that's L1, so that's going to be X minus L1. And then that's going to be minus. And then same as the P2, so P2 will be the P2 times X minus L2. And then we call this Macaulay bracket and just keep this one square. And then we keep this one all the time. And then the shear force at this surface is just passing the pivot point, so no bending moment create. So that's going to be at this location, so we're going to be 0, so we don't write it down. And then plus the bending moment, which is a minus mx. Minus mx in here. Okay, so from there we can get all this one equal to 0. So you move this one to the other side, so the mx should equal to the Vx, Vlx, capital V, this is a support reaction, and then times x, and then minus P1, x minus L1, and then minus P2 times x minus L2, and that's all. Okay, so in here, this going to be a given condition. This is going to be a given condition because how much loading you apply, you know already. And then the L1, L2 is also given because you were given which point you loaded, and then from the drawing there, you should be able to identify what is L1, L2 going to be. The only thing is VL we don't know yet. So to find out the VL, we need to use equation of equilibrium for the whole structures as well, right? For before. So what we need to do is that actually we should do it before, but anyway, we write out this one here is m about this one equal to 0, and then but this equation of equilibrium to find out the VL, we need to take bending moment about the point B. Say if this is the point A, if this is point B, and then we need to take moment about the point B. Because one off, the one equation, we can get it. So to write out that one, we also need to write out all the many moments that you have for the VL. So VL is going to times the lever arm. Lever arm is going to be L, right, for this case. And then the second one is going to be the P. Sorry, it's going to be P1. The lever arm should equal to. So if it's the entire beam in here, that will be the L1. Sorry, L minus L1, right? L minus L1, P1 in here. So is this part okay?
Yeah.
Or maybe if you need, if you still need, yes, I show this one here. So that's the distance. Sorry, that's the entire distance L, and that's the two loading you have. This is the VL we are looking for. So you have a P1, P2 in here, and that's distance here is L1. So that distance here is L2. And now you take moment about this point B for the entire structure to figure out what is VL equal to. So that's the lever arm for you pin down this one. So this is the entire length L, and this one is the L from here to here is L minus L1. So next one will be the P times L minus L2. So that's equal to minus P2 and then L minus L2 for this case. And anything else from here? No, right? Because that should equal to 0. Yeah. So from there, you should be able to find out the VL is equal to the P1 L minus L1 plus P2 L minus L2, and then altogether divided by L. Okay, so you will think, oh, this is a very long one. Later on, if I put this one in here, this is going to be a nightmare because they're going to be such a long term. But the good thing is that if you use the Excel to do that one, I don't need that. I don't need this one into this equation because assume this is given. If all this P1, L1, P2 is given, the VL will be a number from the Excel, right? You can find out if all this given, this will be a number. So you just assume this is given, this become a number, and then all the later on, this is assume this is a given condition, and then you can continue the deriving, so that the rest will become very easy. So you don't need to actually put this block into this one. Just assume you got this number in the first step already. Okay. So we'll show you later on how to do that one in the Excel. So and then the next part we want to find out the deflections for this beam. So you need to use the relationship between the deflection and the moment. That was this one, and lowercase v function of x and square, and then dx in here. Okay, so square, sorry. Okay, so that was the relationship we developed before. So to find out this lowercase v, this lowercase v means the deflection. So what is lowercase v? That means it will start again.
You're going to do without recording?
Okay, it start again. Maybe every 30 minutes, and then it will do one click. And so the next one we do is that we just continue to do the integration for this one, and then P2 x by L2 in here. So we integrate this one twice. So the first time, that one will give you, if you integrate this one, so this gives you the EI dVx square, and then dx square in here. So that's actually, oh sorry, not square. So this is the dx. So this one is the rotation, okay? So theta x. That's actually the theta x. And the other part, what we need to do in here is that we need to get this out one by one. So if you use the integration table, you can easily work out this one. So x squared minus 1 over, P1. I just write down the solution now for you. Okay, so don't forget you got the integration constant plus a. So this is unknown. We need to work out later on for this one. And then, so this is the equation for the rotation, but we still need to integrate one more time and then get the deflections as well. So we integrate this again. So we integrate this 1 EI dVx dx. Oh, I forgot this dx here. Could you put it down here? So that's dx, and that's equal to, and then you do this part. It's integral of the whole block. So we got the second term in here, and this one you integrate this part, so that it will give you 1 order lower, so they give you this deflection equation for the deflection, and then so that's what we need to find out the answers you have. So this part we need to do the proper integration for this term, so that should equal to let's write it down here. So it's 1/6. Okay, 1/6 because this is going to give 1/3. So it's a VL, and then x power 3 minus P1/2. So, and then this one, power 6, sorry, power 6. Then x minus L1 power 3, and then minus P2/6, and then x minus L2 power 3. And then you also double check as well, because in case I make a mistake, because I haven't got
plus AX.
yeah, plus AX plus B, that's not finished yet. Plus B in here. Then what we have, the next one is that we need to find out, because this is actually, if you're talking about this one, is equal to this one. And then all this VL is given here already, in here. And all the P1, L1, P2, L2, all is given condition. And then as long as you plug in the X, so you should be able to find out the deflection. That X should equal to where your dial gate locate. Okay, you have two X. So if you put the location 1, you got the deflection on that point. But only thing is that you need to find out the A, you need to find out the B. So that's come from the boundary condition, because at when you see the beam, the two end is two rollers support in there, so the beam not going up and down. So at that location, the X equal to 0, your Vx, the deflection should equal to 0. And then the second condition is that we have the X equal to the sorry, maybe a little bit lower here. X equal to L, and then Vx should equal to 0 as well. So when x equal to 0, when x equal to L, all equal to 0. So from here, you should be able to get the answer when you put this one in. So EI that the Vx, EI V0 is equal to, and then the whole block here. So it's 1/6 VL x3 minus P1/6 x minus L1. And then let's switch off this one first. You can switch on. And then so minus the second part is the P2/6 x minus L2. And then plus A times 0, because that time x equal to 0. Oh, I should put in 0 for all. Okay, I'll do this one, use the red color. Okay, and then plus B. So because all this should be equal to 0, so this should be equal to 0. This should be equal to 0. Equal to 0. Okay, and then this side, because we said this one, when x equal to 0, this equal to 0. So that part is equal to 0. So this sign cancels. And do we need to consider this term?
Sorry?
Do we need to consider this term when we do the calculation? So this term should be ignored. Okay.
Yeah.
And then yesterday we mentioned already, if this is 0 minus L, this must be a negative value, which means you consider something far to the left, and then the P1 is not in the left-hand system, so this one should be ignored. So all this should be ignored. So ignored because this is negative. So this ignore. So that's going to be because this this one is negative. And then that's going to be ignored. And that's why we call this one is a Macaulay bracket. So when you do the integration, keep all this one all the time, don't break it. So when you come to the final equation, and then this one will tell you the location. So when this turns negative, means your x is moved back, and then you pass that loading, that point loading, or the other patch loading already, so you don't need to consider that term anymore. And so if this is ignored and this equal to 0, and then that you can easily get the from there, so the B will equal to 0 immediately for this term. Okay, this is easy. So get A, and then for get a B, and then for A it's slightly complicated. So A is going to be the EI, and then this one. Okay, so this is a capital one. Okay, so still not. This is a lowercase one. Okay, lowercase one means defection. So this is defection. So that's at location L. So this should equal to 1/6, and then VL, and this is a capital L, which is a support reaction at the left hand side. So times the L cubic minus P1/6, and then L minus L1, and minus P2/6, and then L minus L2, and then plus A times L, and then B equal to 0. We don't need to consider in here. So this side, this one equal to 0, as we set here as a boundary condition. For left hand side, when the x equal to L, the defection is supported, so they're not going down, not going up, so the defection is 0. So this side is equal to 0. So that will be pretty easy. So you get A will equal to, and then remember you get L in here, right? So we take on 1/6. So if you want, you put the L here first, okay? And then that's equal to VL, capital V, and then L cubic minus P/6, and then L minus L1. I make one mistake, sorry. And this power 3, I forgot to copy down, okay? So power 3, and that's going to be power 3 as well. So that's going to be power 3 divided by L. Oh, no, later, okay. So minus, plus P2 divided by 6, and then L minus L2, and power 3. Right? So then we divide by L, because you get L here. So this divide by L, so this becomes second. That will be the square. So this divide by L in here. Okay. So once we got that one, we can take off this one. Okay. So that's the equation for A. And then if you put A back to the equation here, then you got the defection for the whole term as well. So finally, once we got all this one, we can conclude that the equation. And remember the A here. You look at all this A here. So all this number VL, L, and then L1, L, and L2, L is given. Okay, let's just continue on that. Okay. And then once we finish this one, and then we start to do a little bit Excel, we take a break, and then I have a look at what the issue on there. So you got this VL, and then you have the this one x power by s cubic minus P1/6, and then x minus L1 power cubic P2/6, and then x minus L2 cubic plus AX. And then you don't need to copy this one down, because in Excel you can do all the calculations. You get VL first, get A first, and then later on you just use one single number here. That's done. Okay. So this is the final solution. Assume the A can be calculated from here. So that's the equation for the deflection. And don't forget, at this side you have EI as well. So that's total. Should divide by E and I. So that's the Young's modulus and the second moment of area. So that's get from your dimensions. So that's the complete solutions for this structure. So once you got this one, you should be able to find out any place. So if I have a L1, L2, and then I have a P1, P2, you just need to use the equation to do it. And then that's much easier already than you're doing these procedures from beginning to the end, right? So this is a one-off deriving, and then a general equation for all the case what you're doing. And then I don't want you guys, of course, you get L1, L2 exchange, and then it can be the other guy's case. And then please don't copy the Excel only, because it's not the purpose of doing this one. But if you hand in, if I find out 2 copies exactly the identical one, and then I'll come in to interview to see that is it true, or and maybe ask you how you produce this Excel, and then demonstrate to me. And then if you can't, if it's confirmed it's copied from the other one, you two will share the highest mark. So okay, so don't copy from other guys, and don't allow the other guys copy from you, because it's get caught, you two just share the highest mark, and then because only 1 copy will be marked from there. So this is very important. And then the next one I show you. Actually, if you work together with me today, you should be able to get the answer today. So all the calculations done today by this afternoon. So let's maybe work together on here.
Is that for Excel?
Yeah,
I'm going to use Excel now.
Yeah. So what we need is we need the several equations here. So I mark out here. We need this one, okay? And to get that part, we still have the VL and the A to find out. So we need the A from here. We need this one. And so we also need the VL, which is this one. Okay? So let's have a look at the Excel, and then how we work out these numbers.
So is this what we're going to do for the 1-point load and 2-point load as well?
Any case.
Any case.
1-point load, 2-point load, the difference is let the P1 equal to 0, equal to 1-point load. Okay. And can I ask you to start your Excel?
Yeah.
And then maybe I enlarge a little bit the spreadsheet, and so you can see clearly. And then let's do this one, because you have different low case. So you create a low case in here. So the low case you have, maybe we do only one first, and then you can maybe make it smaller, and so I just forget it first. Yeah. Let's do the formatting later on. So this is number 1, and then the dimension to create your case, you have the total length of the bin, so that's in millimeter. So we have all the dimension in here. So what the dimension you got? B1, let's say we have a 2700. That was because the total is 3 meter. You take 150 off both sides. So from support to support is 270. 1700 millimeters. Okay, and then the L1 is in millimeter, and the L2 is also in millimeters. And then can I ask who is doing B1? Maybe we can use your data to do B1. Maybe you got your data here, the test data.
I'm not sure. No, I don't have it at home.
You know,
But I have a picture of him.
So you definitely I could give you an idea.
No, but he's already okay. I have it.
yeah. Okay. Let's say we later we put in the number in here. So so you got your B1. Don't have the lens, okay. Let me do it this way. Let me just randomly put in something first, okay? So I put the A50, which is number A, and then I've also put in 1A50, which is middle, okay, of the beam. So that's L1, L2 temporary. So then later on we can maybe use one data to do that one. And the next one, because the loading you have is the weight P1, P2, which you need to add on. But we not add on the P1, P2 directly because P1, P2 is in kilonewton. We add on the weight, so we load the weight on. So we just put down what we have got here. So weight 1. So the weight 1. The unit for weight 1 you put in is in kilograms, right?
Yeah.
So kg. And then that's one. Say let's say I put in 30 kilogram as temporary data, and then you need to convert this one into the P1, the loading in kilonewton. So that was actually the one we're going to use in calculation. So the P1. And zoom in a little bit to make sure you see the unit. So the P1 and the P1 is in kilonewton. Okay. So let's say I use the kilonewton to represent the as a unit for the loading. So I need to convert this one to the newton. But to do that one, this is now start the equation. Okay. What I that require you to do, don't put the number. Say if you put in here equal to 30 times something, and then the next time you put the P in here, the different loading in here, this P1 won't change. They will still keep the same. So to enable you to do that, what the best way is that you code the cell. You code this cell by position rather than put in number. So to input this equation, can you follow me this one, because the first one, and then it's important. So double click on this cell, and then you can activate the cell. Now you can see the cursor's fraction, and then key in equal to, and then after that you move your cursor to the next cell, which is the number you want to code, and then click on this one. So they will reference the location. So we won't reference the number, but reference the location. So later on, anything change in here, this one we're going to change automatically. Okay, so that's equal to E2, and then in the surface of the Earth you have 9.8 gravity constant, and then that was the meter per square second square, and then that's give you Newton. Okay, that's give you Newton, and then you need to divide by 1,000, so give you the kilonewton. So after that, you got the kilonewton in there. So because all the data here, let's say, is we need to key in this data. So maybe just mark it, highlight then. So this is the key in data, and then this one is calculated automatically by the computer, and maybe put in the other color to show them differently.
Just change the color.
Yeah, you can. It's whatever you want to do, but just I use this color code. I will know that from the column B to column E, this data, I need to key in. I can change them. This is input data. But the P1 is will be the data that going to generate automatically. So if I want to later on, if I change the P1 to 50 kilonewton, I just need to type in here 50, and then you can see the next one change automatically. Okay. Okay, so that's the way you do, and then you don't need to even use the calculator to do it again. So that's very convenient to do in this way. So theoretically, if you've got your data here, you should be able to finish all the calculation this afternoon. Yeah. So if you follow me together in here. So let's put it back in 30, which is the one I have at the moment. And the second one is a way 2, so we need to create a way 2. So way 2 is in kilogram as well. And then what I need to do is that I create the second cell, which is a P2. That's in kilonewton. So all this later on, if you get a chance to do. So what we're going to do, the next one is going to be the VL, because we need to find out all the data now since ready. So we need to find out the VL. So to find out the VL, what we can do is that we leave a space here, because we need the variables x. We need the location x here. So we leave this one as a spare space, and then the next one we put in the VL. And then VL, that, as you know, this must be in kilonewton. Okay, so because all the loading you have, all this one is in kilonewton. The outcome will be in kilonewton as well. So we put in here, see, in kilonewton, and then we need to input this equation into this cell. So when you do this one, remember when you want to pick up P1, and then you need to move your cursor to the P1 there, and then click on the button there. Okay, so to get location. So because I can't get all the L1, L2 in one screen, so I zoom in slightly so I can see both in one screen. So I got the L1 and the P1, P2 all in one screen. And then, yeah, P2 need to be color coded as given what you call the calculations as well. So then we come back here again. You just double click on this one, and then key in equal to. So equal to the first term. Remember this one you got in here is P1. So you move on to the P1, which is this one in here, and this one. Just click on here. You see they will give you the location in here, and the times the multiplier is using the star key to replace, and then that will be times, and then you need to keep all this one for everything. So you cannot say like x minus x times something, and then the middle one you don't write when you derive your equation. Yes, you can do that, but in here you have to put in a star in there. Okay, and the next two you need to use the bracket to cover it. So that's equal to the L minus L1. So that's going to be the L. Oh, where's L? I didn't get L, so I need to move a little bit. So this is L. So L, and then if you can't see the cell there, you can see this equation there. Okay, so that's B2 now is coded in. So I move back a little bit. So and minus L1, which is the L1 in here, and then close it, and plus the P2. P2 is going to be this one here, and then minus times. So need this one all the time times the L minus L2. So will be L is this one, and then I come back to see that L is there. Minus L2. L2 is the second one here. So let's click on this one. So after you finished, and then close this one. And then when you divide by L, remember you need a bracket to cover all this one, because it's a whole block divided by L, not only last term divided by L. Okay. So that's why you need to move your cursor to the front between the equal and the F2. Click in here. So locate your cursor in there. Okay, in this one. And then put a bracket in there and close all the things in here. and then divide by L. Divide by L, and the L is going to be reference again, so you come back to here to click on B2. Okay, so that's the one in here. Okay, that's a full equation. So once you have done this one, press enter. You got this number there. You get in the same. If you got if you can keep all the number here, keep all the number the same as me. So every time when you key in this one, you should be able to find out the exact number for this case. Okay. So I just double check my number. So don't follow this one. Okay. I just do my checking in here.
I got 0.23.
Yeah.
Did you put brackets?
Just change your Oh my god, I got minus 1.
It should be
Sorry, could you... What was it? Is it F2 times U2 minus C2?
Go back.
Can you show me?
Okay. So I just double check my number. So don't follow this one. I'll come back to show to you. Okay. So forget. And
almost like your 5 and 10.
I'll zoom in a little bit further. So that's the equation you have. So you can see if you're not quite familiar with this one, you can look at this one. So you can check all this equation F2, which is this one, correct? P1, and then times the B2 C2. So that was this one minus this one. Yes, correct. And then you just check all this equation, make sure it's correct. Okay. So you get in the same.
Yeah.
So you get the same and press enter. And this one supposed to be the compute number. So we color code it as this one. And so now we got the VL already. So to get the equation here, we still need the A. So we still need this equation A. So I move up a little bit, and then make sure you can see in here. Oh, but I can't. Maybe I move this down. So move this up. So that's A here. Okay. So this is the A equation. And then when you find out the A, remember this time. Do you need X in here? The A, constant A. No need. Still no need. Okay. So everything is L, P1, P2. So and then VL as well. But VL we already got here. So now the next one, what we need to do is that I zoom in slightly in here. So the next one, what we need in there is the constant A. I put in COST A. Okay. Constant A in there. So for this one, we need to input the whole equation, that one in here, okay? And so let's key in one by one. So this is equal to, and again, equal to the 1/6, minus 1/6. So I put in 1 minus 1/6 first. So that was the minus 1/6, and then times
Should you put brackets too?
the first one maybe no need, because this is a divide by L only for this time. This divide by L only for this time.
The minus 1/6.
That should no need. No need. And times this part, and then you can times the VL. VL is this one, okay?
6 times.
So VL is the this one, which you already got. So you click on this one, and then times the L square. So times L square. So L is this one. So click on this one.
Times L2.
So the square you can use this one, okay? This means power 2, okay? So power 2 and put in here. So that's above the letter 6, the number 6, sorry, the keyboard 6, okay? So use this symbol to represent the power, so power 2, and then plus, then this one is P1, sorry, this is a P1. I make a mistake here, P1. So that's P1, and then what we can do is that you can choose the P1 in here, and then divide by 6 times the L minus L1 power 3. So you use this one bracket, and then L is this one minus L1 will be this one. Close it, and then cubic. So it will be using this that chevron again, and that 3, and divide by L. So divide by L. L is come back to this distance here. Okay. So that was the second term, and then you add to the P2 over by 6.
Is the whole thing divided by L, or is it just that like part of it that's divided by L?
It's only this, because if you look at this, then this equal to 0. Okay, so that's moved to the other side, or this moved to the other side, and then that's divided by L. So the L cancel here. This divided by L. This divided by L.
Bracket in here.
Okay, you got it. So that's only this one only responsible for this one. This one responsible for that one. Yeah. So plus the P2, so P2, you click on P2 is here, and then divide by 6, and so times L is going to be this one minus L2, so click on this one, and power 3 divided by L. L is B2 again.
Can you leave that for 2 seconds?
Yeah. So now, I think you got the VL ready, right?
Yeah.
So you got VL. Is everybody done here?
Wait.
So
Is it B2 minus?
B2 minus B2. So yeah, look at this one rather than to look at my one. So you need to convert this equation onto there. Okay. So just that's easier. Otherwise, you follow me. This one is meaningless. Because it's better you look at this equation, just try to translate to that equation yourself, and then rather than just randomly copy
same
my one.
numbers as you.
You getting this? So everybody done?
The syntax for the arithmetic is really weird.
Sorry.
The syntax for the
Just
arithmetic.
saying like this.
You got it. The syntax for the arithmetic in Excel, it's just weird because it won't work when you actually write it down. Because, for example, it says -1/6 times L2, but that's first divided 1 by 6 and then times.
Yeah. But the way it works, they won't understand what is L2 or L3. They only use the reference address of the cell. The cell you get which row, which column. So every number in that column is going to put into the as equation. So if you replace the value in the cell, and the equation automatically change.
So what's your answer?
The answer is this one. Okay, have you got the same?
Yeah.
Okay, so I just double check the number. And then what I think the next one, what we need now, so we need the x coordinates already. So let's put in, so where you want to find out the diffraction, so this is actually the variables you need to put in. So x equal to, say for this case, will be A50, will be the point A, and then the 1350 will be point B, and then so on and so forth you can do. So that's the x coordinates there. So let's say if I put 1350, that's going to be the middle point. So this is the location you're going to key in. So I'm going to mark this one, the red color. This is actually the input numbers. So if you change the red color, everything, they will change the location for you. Or maybe red is not easy to read. Maybe I change to maybe slightly different color. This one, okay. And so the next one, we need to find out the different values for this one. So we need the v now, the equation v here. Okay, so that's actually the final term. We need to get it from there. So what I suggest is that when you look at this one, and remember when you put the x in, if you put the x in, if x equal to say for example, if equal to 350, which is very, very close to the left hand side, and then the L1 here is possibly going to be 350, sorry, 850 somehow, so this become negative, right? This become negative. So I want to find out that a function which can allow me to do this one automatically rather than I need to do that one, because if I input this equation into the Excel won't know, because Excel just purely just math, they do the math for you. You put the 0.5 here, and then the other one's 10, and then he give you a number out, but they won't be able to take out automatically for you, because in our situation, in our Macaulay method, when this one becomes negative, we need to ignore this term. Am I right? So we need to ignore this term. So we need to do this one. We need to find out how can we do this one. How can I ignore this term when the inside part become negative. So to do that one, let me show you a way to do. And because it's hard to do this one in one go, can I try a simple one first to let you practice? So instead of doing this term, I'm doing the maybe x minus L1, and then that times x minus L1. Just do this term first, okay? Just do this term, okay? So when this term, what we're going to have, when this term equal to 0, that's smaller than 0, should equal to 0. Okay? When this one larger or equal, smaller than equal to 0 should equal to this one. So larger than 0, so that should equal to x minus L1. So right, that's what we should have. And if we can do that, then we can do this one, no problem at all. So let me show you how to do it. So to do that one, we need to use a function, which in Excel is an if function. So the if function, how they construct this one, that if you have a logical test in here, logical term in the first one, so you will test x minus L1 is larger than 0 or not. So if larger than 0, the first one will be the actual value. The actual value will be x minus L1 when this logic test is true. And then when this is false, it's not true, that will be this case, and then you put a 0 in here. So which means if this term is become negative, they will return this one. And then the whole term, anything turns there, give you 0. And if this one bigger than 0, they will return the original numbers to it. So that was the way we do then to implement this one. So let's test this one here. So just try, see whether we can do that one. So if I put in this one equal to, and then immediately you type in if function. So this is the if function. So, and then if you put the bracket on, that will give you the syntax of the if function, how you should use it. So the first one is the logical test. So the logical test we said before, we want to test x, which is x minus 1, so we need another layer of bracket, so we need one more bracket on. And then it's x, which is k2, minus, we use L1, so we pick up the L1 in there. And then we put in the bracket back, so this is going to be the logic test turn, the first part. And then if this one large then, so we put in this one, large then 0, and then we can let this turn equal to x minus L1 again, then we can click on this one, x minus L1. So this is going to be returned if this anything inside that one is true. And then otherwise a comma, and then otherwise I will return a 0 to it. So this is a complete one. And then you need to close this bracket, the red layer, so you can see the red one closed in, and that's all.
Press.
So if you're done, you press enter.
Gives you 500.
Yeah, they give you the 500, right? So this gives you the right one. But if you choose, if I change this one to, like say, 350, if this one 350, smaller than 850, there should be 0. Okay, automatically. Yeah. Okay.
Click that equation, get the formula back in the book.
Okay. So maybe I move a little bit further in here. So if K2 is that x, right? K2 is x. If K2 minus C2, x minus 1, larger than 0, and then it will become the case, second case. So that should actually return this actual value to it. So that will be the K2 minus C2, and otherwise return 0. And then, so if you can use Excel to do that one, you don't need to do the calculation, and then just let Excel to automatically choose the proper one. Even that x x become negative, they will automatically make judgment there, and then calculate the proper one number for you. Okay? So, you got it? Everybody got this one? Yeah. You press enter, and then you should have the answer. And then we change this one back to the 1350, just later on. We going to do that part later on. And then in our test later on, I guess we're going to put on all the turn in here, okay? But the only thing is that will be very easy. You make mistake for this part. Say for example, if you input this long turn, I guess you're going to be a trouble because you make one mistake inside the equation will be long and very hard for you to find out. So let's do in this way. So can I define this turn? So I'm going to define this turn as turn 1. Okay, this is turn 1. So this turn is turn 2. Turn 2, okay? This one is turn 2. So we do this one several turn first, and then after that we put this one all together, and so that will be maybe easier for you. So now we don't need this one, we don't need this part, so let's delete this one. Just highlight this one, delete this one. This is just a test for you to learn this one, so we don't need this one anymore. Let's do the turn 1. So the turn 1, and then so the turn 1 is equal to this one minus 6, and then this this x minus L cubic 3. So this one we need to use the if to do it, right? So because when this one minus L1 bigger than 0, we return the odd turn. If it's otherwise, we return just 0. Okay, so we need to write out this turn. So can I do this? Can you follow me this one and then?
There's no first year stuff.
Okay, so I assume you got this one already, right? So that's the same number. And now we do the turn 2. So can I leave you to do the turn 2 yourself?
No.
Okay. Turn 2 is just if x minus L2 greater than 0, return this term, otherwise 0. Can you try to convert this from yourself? So just this one. Don't do the long one first. So turn 2, you need if condition as well, okay?
Where's the second one?
Could you click on
Turn 2 here.
So P2.
Here, this one. No, do not just. Step.
P2. No, this is the same one. Wait, you leave it off for a second.
So turn 2. What?
No, it's if that one's more than 0.
Yeah. If greater than 0, then you equal to.
Should we do turn 2 for?
Sorry.
Yeah.
Instead of C2, you just go C2.
So I think the better you try a little bit. If it's when you press enter, and then we can check the number together later.
So we could like.
So if that's so what you need to do is that actually I write down here, okay? So then so that will be if, and then the x minus L2. So x, you look at this one. X is K2, right? X, you pick up the coordinates. That's going to be K2. And but of course you need to bracket one more bracket in here. K2 minus L2. So L2, you look at that one. L2, the one is a D. So minus D2. If minus D2, if this one, that was the actually the inside part is the x minus L2. If that part bigger than 0, then we return this equation, which is a P2 divided by 6. So P2, you look at the P2, where's P2?
H2.
P2, H2, yeah. So you put the H2 divided by 6, and then times that one L, and then L, the distance is B2, right? Oh, no, sorry. So X is a K2. So K2 minus D2. D2 is L2, and then power 3. Power 3. So that then you convert this term into Excel equation. That equation here, and that was the one you should return when this when the internal part, this part is greater than 0, and otherwise return 0. So you put in 0 at the end and close it.
It came up 0.
Huh?
It came up 0.
It came up 0, of course, because your K2
Is less than.
is your K2 your X2 is the is a 1A50, and then the X is equal to this one.
So it's less than.
Less than once it return to 0. And then if you want to check whether it should be the right number or not, you put in maybe 2 meter 500. Sorry, 2,500. So that's equal to.
It's D2, not C2.
You got 400.
Because it's L2 you're using.
Yes.
You've changed wrong. It's K2 minus D2.
Yeah, it's X. It's X minus
Okay, so that's a 0 here. So if I change this one to, let's say, because L2 is A1A50, so I change to maybe 2 meter, right? 2000. Let's check whether you get the same number. Are you getting the same?
No.
165. Let me, maybe my mistake, okay? So this one is divided by 3. Okay, my one is correct.
Yeah, I got this.
H2 divided by 6, K2D2. Yes, my one should be correct.
Yeah.
You get it same. Yeah. I checked my number.
No, you need to change it.
You need to change it to 2 meter. Okay, change 2 meter. Then let's double check the number 10.2. Is it the same?
2 meters.
Yes, just temporarily change. Because
Yeah.
when you get the equation, the x can be anything. So you just dump in different x, you get the result for you. Okay. Okay. Have you got it?
Yes.
So if you got it already, then let's change this one back to the same number, which is 1350, which is original before 1350. And then the next one, can I maybe zoom in a little bit smaller so I get the this space in here? And the next one we can write out the whole diffraction in here, right? So we can get this one now. The final v, that was the Vx. So Vx it is function of x, but the unit is x. Unit is a millimeter in millimeters. So then what we can do is that we need to input this term together and then divide by EI. So what we can do here now is that will be simple. We just assemble them together. So it simply add up. So that's equal to. I do the first turn for you, and then you I do the first and second turn. You finish off the other turn. Okay. But remember, you need to bracket in here divide by EI, and then the EI need to bracket as well. Okay. So that's equal to that 1/6, and then times the VL. So if you look at the VL is this one. Okay. So we don't need. You see, I don't need to know. I don't need to input the whole matrix VL in here. So I just need to pick up the number from there. So that's the VL. So we got the VL in here, and then times the x cubic. So will be times the x cubic will be this term. Okay, this term here, x cubic, and the cubic. And then minus 10.2. So minus 10.2. So you just simply minus. So the whole block we already got. So we just click on 10.2. Click on this turn. Turn 1. Sorry. Click on turn 1. And then can you do the rest? And then plus EI.
So you minus. P2 over 6.
What's that?
Okay, so I'll continue myself. I assume you've done that one already. So minus
10 to 0.
10 to 0. Yes. and then plus the a constant a times x times x. And then close and divide by EI. So EI, because EI need to put a bracket in here, okay, cover this one. If you divide by E times I, then there will be divide by E in here, and then this I times the whole term is completely wrong. So need to divide by EI, so the EI should be in bracket. So we use the E, and then times the I in here, and then close it. Okay, so that's the term.
Do the bracket?
Yeah.
That doesn't need to be, it's that 4 times 2x. It's that whole thing.
1/6 VL
What's the result? Sorry, the result. The result. I press the enter.
Why are you doing it? When do you
Get a sense?
Can you go back to
I don't want you to put the way my
Because it's P, right? Term 1 is P1 divided by 6. So it's 1 divided by 6 times P1.
It's weird because you've got R and then you've got
Yeah, which is what I did.
I mean,
Okay.
nah, I knew that.
You're right.
Yeah, like 3 minus 0.898. What do you do?
So I just need maybe one bin B1. So can I get your L1, L2? So
my L1 is 1,350.
1350. L2?
It is halfway, so 1850.
1850. So L2 is this one. So you are bin B1, right?
Yes, B1.
B1. So the total length is 2750. So 2700.
Yes.
Okay. And let's see the case 1. You get 2 loading. Case 1 is how much kilogram you got?
10 and 0 are one.
10,
So
10,
10 at point, the midpoint.
10 at the midpoint. So what the other one?
0. Like there's already 10 on it.
Yeah, yeah. The second case. Second case.
I didn't put any.
You must have went after you've done the 10. You put the 10 on, what you put on the next one.
I put 10 as well. Task 1, if you put 10, there's already 2 10s on it, then you put 10, you 0 it, and then you put a 10 kilograms,
Yeah.
and then you take it off, then you put a 10 on the other.
No, you were given a number. How much?
So you put it 20 on the 1-point load and then take off, you put 20 on the other side. You're 15.
What did you put in your point 1?
This is what I put, 50 and 50.
It's 50 and 50.
So that's given in your table.
Can we use someone else, please?
Yeah, maybe use.
Just 10 kilograms.
Jimmy, can you use yours one?
I probably did the lab wrong then. What the hell?
Just go to Spectral
10 on mine.
Yeah, like on mine.
Remember, give us a spreadsheet.
So are you getting the same? Maybe otherwise we switch to the second one. So.
Your face.
Go to Spectral Shining then.
I didn't see. No.
Go to Spectral.
Okay, fine. It's
I
not
just
problem.
did the task 1 and task 2 on the report thing.
It's not problem, but in your report just indicate what has been wrong, and then, but the calculation should be the same. If they match your test, it should be okay. It's not a problem. Can
Jimmy,
maybe we use the second, the other student.
are you B1?
What's that? What does that mean?
Who's
B1?
been B1?
I'm B1.
On which task though?
That's
You
what
get,
I send you.
you get the data.
Did you get it? Did you use that? Or did you just
No, I
write
just,
it
there
down?
was 2 tabs on them, I zeroed in, and then I put
So-
10 here.
Your
So one is
10 on
850.
the other one.
A50.
That's our shit.
Yeah, and then 10 on both sides.
1850.
So you'll play the second half.
Wait one,
Yeah, the second task is
20.
You did the first half right as well, you just didn't use the right way.
and the other one is 0, right? The case one.
Huh?
The case one is 0.
Oh, case
Make
one.
it easier.
And then, so the
X
where you measure point A, your point
Point A.
one
Point
is
A.
350. The other, maybe that's not the good one. Find the other one, the bigger one.
That's what I should have done
Big
B2.
I did, what is it, A and C, so if you look at this column, so 1,350.
1, 3.
It was off. 5.
So can I get your measurement for that?
Oh, I don't have. Oh, wait, I didn't.
Well, that was a good point if you don't have a measurement. We tried to pull that, the calculation.
0.19.
0.19.
Yeah.
Okay, so now
Okay, so let's see, so you had 20 and 50. So you have
okay, now let me show you here. Say what if you want to use this table, how to use it. So
Oh, wait, no, sorry. Sorry, I got 0.31.
No,
Wait, huh? Wait.
this,
Where measuring?
this no point C,
Measuring point C, yeah, so 0.21.
0.31. 0.
Well, negative.
0.31. Okay. So 0.31. So that's measurement. That's the actual calculation. So not too bad already. So because our beam is too big and then slightly big, the loading we can't load too heavy because for the safety reason. So it's close enough. You can see from there. And then what we can do is that if you want to use this one, so you basically just need to change L and the L1, L2. For every student, when you put the L1 and L2 in, that will be fixed. That will never change, right? The only change is the loading. So you need to just create the loading in here. So let me show you how in your report what I expect you to discover for this one after you do this after you finish this one. So this case what we have is that for only 1 point, and then we have the loading on single point P1 is equal to 20 kilonewton. So your second point is equal to the second case 2 is equal to 30 or 50.
50.
Case 2.
0.8.
No.
The loading.
50.
Oh, 50.
Yeah, 50. So then what I can do is that so the x is equal to c. So that was your the measure point in the middle, point C.
Yeah.
And then the other point is here. It's too close. I didn't use that one because that one is quite small. The error could be quite big. So this is something you can discuss because different people they get different one. And then the middle one is more reliable. So we use the middle part to have a check. So if you have the case like case 1, case 2, case 3. So case 1 plus case 2 should equal to case 3, right?
Yeah.
So that's what we should have in the case 1. So what we can do is that after you finish this one, can you also change all this data to his case first, and then we can use one to have a check. So the length is 2,700 the millimeter, and 850 for L1, 1850 for L2. So weight, the case 1 is 20 kilogram. And the weight 2 is 0 because you don't load anything on the right hand side. And that's it, so that the rest part should be automatically get it. And then the location of the measurement should be the middle, so 1350. So the x should be changed to 1350. So that's the point C. And then you possibly get the other point, you just need to change x to that location, will be fine. And then, so the data you should have is that case in there.
So,
So-
x is over the point where you want to find deflection, is that right?
Yeah,
Yeah.
yeah, that was, Vx is actually the deflection at that point.
So at that point the deflection is 0.2.
Yeah, it's 0.279, and then you got measurement on the 0.31.
So if you do, for example, P2, if you do 50.
No, don't do that one yet. I'll show you how to do this one. So the case 2, what we can do is that now if you got this correct, and then I can copy this down, but till the Vx, so we can copy this down to the second row. So copy, Control C, and then come in here, and then paste in here. Just use the first paste, okay? Don't use second. Use the second will only the number, so you will not copy the equation. Use the first one, so all the equation will copy down as well. So once you click on copy, and then you can press ESC key to cancel the copy, and then you will be able to see that the second case, the one will be exactly the same, but all the reference point, the reference one row lower. Okay, one, yeah.
Can you do that again?
So what you need to do is that just highlight this one, and right click on copy,
Okay.
and then come back to the next row. But make sure you locate this cell in the very front, the column 8, and then at this point, and right click, and then use the first paste. And use the first one, don't use the second one, okay? And after that, press the ESC key to exit the copy mode, and you got the second row. So the second row is supposed to be case 2, okay? So I change to case 2,
This is loading.
and then the loading you have, the location 1, P1 should be 0. You don't have any loading in there, right? And then case 2 for you is a 50, right? 50. So that gives you the 50, the information there. So can you get your lab result for me?
For C, point C. Is it for point C?
For point C, yeah?
0.81.
1 minute, okay.
Wait, what did you get 0.2, 0.494?
Where is
I'm checking my results.
So you get P2, so weight you go 50 and then P2 you go 0.49. So
this one?
yeah.
Your 50 is kilogram.
No, the next one.
Yeah, but it still works.
This one, you should use the equation to get it. So the equation,
Oh yeah, to find the newtons.
yeah, yeah. That's the kilonewton.
I only put 10.
Okay, can I get your lab data?
0.81.
Minus 0.81.
That's why my numbers were so good.
And so slightly different, but you can not exactly. Sorry,
It's close enough. I didn't even
it's
like
close enough. When you draw this, when you do the analysis, then you need to find out why this error come from, where this error come from, and then discuss on this one, and then comments on data. So this is the second one, and then the next one we can copy the case 3. So let's do the case 3. So you select the case,
And the briefing was like
select this one again, copy to the next row, okay, and then this time you need to change this one, which is 20, the P. Okay, so if you get to this point, let's select the last row. So highlight the last row, press on the left button, and then keep it on, and select the last row, and then you move your cursor to the small square in here at the bottom of this one. So you see, if you move close to that one, inside this one, that become a cross. So when you get the cross, and then hold on your left button, hold the mouse button left, hold on, and drag it down. 2 rows, and then release it, and then you got this one down. Okay, so make sure everybody got it, right?
Yeah.
Okay, once you get it, can you change the loading? So change the loading from that weight 1 is 10, the second one is 10, and then 20, 20, and 30, 30, 40,
0.
and 40, and 50, and 50. Okay? So,
See your modulus and your x, they've adjusted as well.
It gets bigger and
You mean
bigger.
here?
No, on the
Thing is,
spreadsheet.
oh yes, yes, sorry. This one, I guess, is some mistake there. We need to check all this one, make sure they, if this one changed, is not correct. So what we need to do is that we need to change this one back to 10. 210. Okay, so just double check, not other things.
Your X values changed as well.
Calm down, right?
X changed.
There's so many things actually.
Chill out.
This isn't
Okay.
You need to push it.
So this one also. Okay. So that once you finish this one, that's going to give you the measure point C. So your measure point C, the diffraction in here, and then so have you got the same number? Got the same number? Yeah? No? So if you haven't got it, could you raise your hand? You got same number? Just check this row. Vx should be the same, right? And if you have a problem, you can just take the first row and then copy 5 times. That will be the same. And then later on, just change the loading to that one. I just before I move on next one, I just check.
Yeah, that's close enough. No, that's
This will tell you. So you make judgment, measure point or loading point. And okay, so once just double check everybody got the same. Okay, so you got the same as well. Okay, now what we can do is that can I get your lab data for that one as well? So then I show you how to plot out the comparison in the lab.
0.32. 0.32.
0.32.
0.64. 0.96.
0.96.
1.29.
Sorry?
1.29.
1.29.
1.61.
1.69.
61.
what about you?
Okay, so this is one of the test data I got here. So I'll mark here like this is the lab result. So what I'm going to do is that I'm going to plot out the data. I'm trying to see that from the lab and from the numerical theoretical calculation what the result looks like. So can I do in this way? Or delete this row. So I'm going to create a data set in here. So this data set will start from the 0, and then that was the 10, 20, 30, 40, and 50. This is the loading in kilogram. Sorry. And then for this one, it's going to be the Macaulay measure. I put it in MC, Macaulay measure, to represent the Macaulay measure. and or maybe MCN, okay, MCN. And the second one is the lab result. And the data we have in here, of course, you set 0 at the beginning, so both are 0, right? So all the lab are 0. And then when you plot out this curve, if you use negative value, the curve looks like this. So not easy to see. So I want to see in this way. So that reverse every negative to positive. So I let this one. The MCN is equal to negative minus of this one. So minus P6, and then press enter. So this minus convert to negative, convert to positive already. So you drag down from there to the bottom. So you see all this one convert to this one. So to drag down is just how come to this point.
What did you do?
Yeah. Say you got the first down, and then you move your cursor to here.
No. Before that.
Before that, that's equal to minus P6. Just reverse then, because I want to get a positive one. Then otherwise you draw. You can, if you're in a coordinate, it's negative. It looks like this. And then normally during the test you measure and then you plot out the curve like this, right? So to make it easy for you to review.
P6 or P7?
So P6. In my case, it's P6, but you should be able to do it. Okay, and then so that's 10 kilograms. So the next one, if you drag down, that's going to be the second one. And the first row here is going to be the weight or the load. So you put the loads in here. Okay. So this is the data table I'm using at the moment. And then the lab result is come from this row, so that's equal to negative of this one. Enter. And then I drag it down as well. So this one is equal to negative Q6, right? So this row is equal to this row. On top you get a 0 in here. The second row is equal to the lab result, which I just key in before. But only thing I need to do is that convert all the negative value to the positive. So take the absolute value of the deformation and then equal to minus of Q6 in here. So minus, and then minus there will be positive. So I drag down. So you got these two properly plot. Not getting the same. Okay, so if you get this one, what you can do, choose this block. This is the final data, and then you go to the insert, this tab in there, and then use the insert the chart, insert scatter, and then use the second one. Okay, using the second one. So which using this one with a dot and then the line in there. So go to insert. And then chart, drag down this one, choose this one, and then press enter. So that's give you the one plot. This give you the one plot of the deformation, the comparison you have in here. So this is the loading you have. This is the deformation you have.
But I have one question. Since we have 2 gauge readings for every load case.
Can you say again?
We have 2 gauge readings.
Yes.
For every load case.
Yeah.
So we have to.
Then what you can have is that you have another MCN here, another lab here, and then you got a 4 row.
Okay.
So this is MCN gauge 1, MCN gauge 2, lab gauge 1,
okay.
lab gauge 2. Then get 4 line, and they compare each other. There will be different line, but they should be each two close each other.
Yeah,
okay. So that's for you to discover, but that was the instrument you got now already. So theoretically, you got this one, you should be able to do all the calculation part in kind of half an hour, should all finish. Okay? But the only things that you need to discuss on all the results, comparison, this is something I ask you to comment and discuss, it's up to you to find out.
How big needs to be a discussion?
Sorry?
How big needs to be a discussion?
It's up to you. It's open end. I want you to,
I'll be for example.
because everybody's data are different, and then you need to discuss on the data you got, are they close, are they different, something
I
wrong in there.
right?
Can I switch on
Sorry,
this?
okay.
Okay.
It's the first time.